for our meetings. Yeah.
All right, so we're gonna be bringing out to RFC a new persistence common interface. We've completed our development of the document. There's a handful of things that Kyle needs to finish up to get it out for RFC, and we're gonna present a brief overview here of what's in the document. Okay, so some of the background here, we originally were based upon COM persistence, so it was iPersist Stream was primary one used. Some iPersist Parquet Bag implementations are out there as well as iPersist storage. We're going to be using this Cape Open persistence starting in version 1.2. I think it's actually implemented right now. The version, what you guys are going to see for RFCs is in Cobia as Cape Open 1.2. So we're using the Cape Open data types. It's one of the things that we wanted to have available is for the persisted objects to be saved in either some sort of human readable format, JSON or XML are suggested. It's required in Cobia. Cobia can't use COM interfaces. Cobia handles the transition, and we'll have a little bit of discussion on how that is handled there, the interop and transitioning. And it allows use of platform data serialization methods where they exist in some of the Cobia language. They're bound to through the Cobia language bindings. And then a single PMC interface is defined to reduce complexity of as opposed to COM, which was had 3 different choices or more. So so I'll go over the object definitions, present some requirements, the interface description and diagram. There's a sequence diagram in here, and go over some and present some of the methods. And I'll also talk about the transitioning in similar fashion. Couple of definitions here. We decided that this could be used in ways that aren't necessarily PMC, PME type of a thing. There may be an object that's hanging off of a PMC that wants to be saved or some other type of need there. So we defined a persistence host, which is the object that's asking for something to persist itself, and then the persistible object is the thing that's being persisted. Typically, the persistent host is the PME. Persistible objects are typically PMCs. There's also a structured data storage container. It's kind of a tree structure. It'll have keys and it'll be key value paired. And then the persistible object, as it's saving itself, can add nodes and name values in the tree. And then the storage medium, you can either save it to a permanent storage, such as a data file or some other ephemeral, less permanent things. And the idea here was if you wanted to create a copy of an object to move it from one thread to another, you could use this persistence mechanism to do that. Okay, to help facilitate multiple thread operation. Okay, so we're explicitly separating the object serialization from storage to the persistent media. Generic persistent host and persistent client allows a broader application, tree-based dictionary that you read write object data using the Cape Open data types, and allows for human readable storage in the data store. So quick view, I pulled out a handful of the requirements. One of them will be that a PMC must support persistence if it can have anything that you can change its configuration. Okay, so if you've got a parameter value that you want to change, you've got to use persistence to save it and then restore it. The persistent host has to store all of the information necessary to recreate the persistence. So whatever the persistible object spits back to the persistence host, it needs to be able to present back to the persistible object. and the persistence host provides the data storage area. It must be one of the design requirements was human readable form. Let's see, the data store is provided by the persistence host. The persistable object as the root node for the tree that it's going to build. The save method is used to place the data using a persistence writer, and then the save method, the persistable object can create and acquire child nodes to build a tree structure, type of things. 13 on the load method, describes how the information is passed back. Skipped a couple here, and the node itself is a key value pair. Child node and key names must be unique. Data storage must support storage and retrieval of any data. Data store must provide lossless storage, so all of the information that's put into it needs to come back. Persistence object must place all information into the data store required to restore this persistent state. So these are the key requirements here for these for persistence. We have three interfaces: IK persist, which has load, save, and you can find out whether the object is in a dirty state. The persistence reader and the persistence writer. The writer allows you to build the tree structure for the data store. The reader allows you to get the information back out of the data store. There's the interface diagrams showing how they interact here. IK persist, here's three methods that are involved in it. Little brief description so that you can kind of see what we've got: a save method, a load method, and a is dirty method. The persistence writer, you have the ability to add a node as a method, get you back a node. That's a persistence, another writer. And then each of the add methods for the different Cape Open data types are provided. The reader object interface basically does the opposite. It allows you to get the values, and then it allows you to get nodes, or to see whether a node is, what the name of the nodes are, gets the type of the value that's being stored, those types of things. There's a sequence diagram showing how interaction between the different objects here. And that was save. This is restore. Different persistence scenarios that are presented within the spec, saving the flow sheet, retrieving the flow sheet, and duplicating the flow sheet are described in a little bit of detail within the document. The next part of this is going to be the interoperability between COM and Cape Open storage and how that's going to work. We have a couple of interoperability scenarios. Transitioning is a one-way street from COM persistence to COBIA persistence. So it's kind of, once you get into Cape Open persistence and you're wanting to save back, you're going to have to go and use the Cape Open persistence at that point. And then transitioning occurs when either the PMC, PME, or both are upgraded from COM to COBIA. And actually, at the end of the day, this will also be to Cape Open 2.0. So this chart shows when the persistence scenarios, interop scenarios are relevant here, and where the two scenarios exist. Okay, we have an appendix in the document that describes this in more detail. Transitioning, like I said, is the permanent upgrading from COM persistence to COBIA persistence. Let's see, this is used in when you're saving 1.2 type of scenario here. And it's only going to occur once. Once you transition, you're not going back. Okay, So here's some requirements here, a handful of them that seem to be more relevant. That the persistent host initiates the transitioning. So anyhow, I'll let you take a look here for a moment. So I don't want to read every word up there. And then a couple more of the requirements here. We do have concept of stream-based transitioning, which is when the iPersist stream interface for COM was used, and then property-based transitioning is when the property bag, iPersist property bag were used on the COM side. So we do have two different scenarios there. There's a flow chart. I think it's kind of hard to read on this format, but this flow chart will be within the transitioning section. And then our status of this, it's implemented in Cobia and Combia. The text specification is about ready for release for RFC, so you should be seeing it here soon. And we're considering whether or not this can be added to the 1.1 type library, or Malcolm would say that we're going to have to go to 1.3 to do that.
I'm not saying we could add that to 1.1. You cannot require a PME that implements 1.1 to guess that there is suddenly a new form of persistence.
So we'll probably have to go to 1.3 if we do that.
No, it's in 1.2. Yeah.
All right, and thank you for your attention here. Are there any questions on what to expect here?
So could I use the persistence host when I implement it to store it as an XML file, the state?
Yeah, you can. Yeah, you would want to be able to write it to an XML file. Take whatever data is in the data store. You can save it as XML. You can, or some.
It's your choice.
Yeah, it's your choice. We're not dictating anything other than that there's a desire to have human readable storage of the information coming out of a persisting this flow sheet, or persisting the object. Okay.
It doesn't prevent you from storing it as a stream that cannot be read by a human, but the design must allow you to do so.
The DH implementation determines what is the actual format that was written out.
Right.
The persistence host determines that. Yes.
Yes. So it's going to have name value key pairs for everything that's being saved, kind of like a property bag would.
Yeah.
Okay, and then you can take that information, save it as XML, JSON, save it as binary, whatever makes sense to you for your use case.
The actual persisted file, binary, whatever, is bound to that specific persistence host.
Yeah, but that makes sense, because if you store a document in Aspen Plus or in Pro2, it's an Aspen Plus or Pro2.
Yeah, okay.
Oliver, you had your hand up briefly.
Just maybe you said it and I missed it in the talk, but how does this interfere with the old persistence?
That is covered within the transitioning and the interoperability that the grid here, okay, showing what the scenarios are depending upon what type of PME and what type of PMC you have, whether you're a COM-based PMC. But you've got if you're both in COM, you're using COM persistence. If you're both in, nice step. If you're both in Cobia or the higher level, you're using the Cape Open persistence. And then there were two interoperability scenarios depending upon which the host is and which the object is, right?
Which are both handled by Condia.
Yes.
So I don't need to change anything on my side.
Right, as long as you're in say, Cape Open 1.1, you don't have to change anything until you actually go to Copia and Cape Open 1.2 or higher.
Yeah.
Right?
Okay.
So. Any other question, anything online?
I think Malcolm's got one here, but I'll check online.
Check my understanding, one of those first requirements. So a thermo property package B and C in 1.2 can choose whether it implements persistence, the new persistence, because it might not be editable from the PME.
Yes.
Whereas a unit operation must implement the new persistence because something must be set on that unit operation by the PME, otherwise the unit operation is useless. Even a mixer, you'd have to, a splitter, you'd have to specify the split factor and that, so therefore the persistence must be implemented for that to be persisted by the PME.
Correct, but your mixer is an excellent example of one that might not have.
Right, it might not, yes, because the mixer may not have anything that needs to be persisted. So it depends on the type of PMC as to whether persistence has to be implemented or is a choice by the developer.
Yeah.
Yeah.
Thank you.
And a note on that part too, I think if I remember right, we weren't requiring it to be saved. If the only thing that was changed was within ICAPE identification. So you would have to reset the name or the description in ICAPE identification, which would be one of the things that might be changed in, say, a mixer object. You rename it when you stick it onto the flow sheet, right?
Yeah.
So you may rename it. So if that's all that we've done to change the configuration of something, then no, it doesn't need to be it doesn't need to be a persistable object. But if there's any type of change, anything that you can edit within the document, then yes, it does need to be persistable. Okay.
I see no questions online. I think we're good. I think I also just like to stress that I think anything that we've mentioned here today, that and more will actually be in the RFC document.
Right.
So if we felt we went a little bit too fast, you can take your time. There's a good period in which you can actually go through the document, give us your comments, give us your feedback.
But the whole point of getting feedback was doing it in the ATM.
Oh, of course.
Yeah. Well, the whole point is that when the thing shows up, like I said yesterday in our SIG presentation, the whole point here is that when the document lands on your desk, you have some idea of what you're looking at, right? You're not going into this totally blind. You've had a chance to at least talk a little bit about it, hear a little bit about it, and hopefully it gives you a better understanding of what's in the document so that you can make, get through it quickly and make useful comments. I don't know whether useful is the right term there. I think that's a better synonym than that, but you'll have some understanding and be prepared, if you will, as opposed to just this big stack of paper showing up saying, tell me what you think.
Exactly.
So, yeah, we did make it. I think we're only 3 minutes over.
I think, yeah, we actually did really well for time. And I think with that, this was the last presentation. I think we can close the annual meeting for this year. I'd just like to say thank you once again to everyone. Thank you once again to everyone who presented, all the effort they put in. Thank you again to Caesar and Gent for actually hosting us this year. Really nice venue. Yeah. Really appreciate it. We will be sending you a small gift, so hopefully it doesn't get lost in the post somewhere, like Klaus's award did a few years ago. But yes, we will be sending you something as a little thank you. Just a couple of points. I think please remember to give back your lanyards on your way out so we can reuse them for next year. Lunch will be again around the corner. At the same venue, and I think Caesar, for those who are doing the training, where should we meet?
Yes, it's very close to here. It's in the building E2. It's just down the street on the right. Well,
Okay.
you have the GPS location, but it's very close to here.
Okay, perfect.
Where the UFO building is. It's the building, the glass walls building down the street. It's 1 block from here.
Okay, you'll be at lunch and
Yeah.
you'll give directions for everybody that's hanging, right? We'll walk over to the booth.
Thank you also to all the people who are joining online. Thank you for the comments, Olaf. Pierre, I think Sergey is also here and also has also just left now, but really appreciate the feedback online. So. All right, thanks everyone, and hopefully you enjoy lunch. Good.
Next meeting.